Hey, hello. Maybe I should switch to, oh, yeah, hello everyone. Microphone. There we go. Hello everyone. So today I'm going to design a server chassis based on the requirements that you guys laid out on Discord. So I'll pop those up for a sec. Let's see, where are they? Here. So, you guys said you wanted 2U. Overwhelmingly, 2U. No cube, well, 3 people said cube desk. 1 person said 4U, nobody said 1U, so 1U was not the winner. Next up, hard drives. So we're not looking for a ton of hard drives, unless you're looking for 2.5-inch drives. Maybe you could be looking for 8 of them. So most people said they would go either all M.2, U.2, or yeah. So pretty split across these. So that tells me that we tend to want less storage. So like if the pair here is 4 or less big drives, or 8 or less 2.5-inch drives, then that would be, yeah. Would you pay extra for hot swap? No. What would you rather have? An external DC supply, so Pico PSU, or an internal supply? So today I'm going to use Flex, or use SFX, because that's small enough to fit in 2U with good fans. And what motherboard size do you want? Either MATX or full size. Full size 1, I'm actually going to use MATX because that's what I have. Okay, come on, sit. There we go. So yeah, I got an assortment of stuff today. I have a metric tape measure that measures in centimeters that no one will ever steal because this is America. I have a tiny ruler. I have imperial dial calipers. I have an assortment of PCI cards and brackets that I can measure. Over here, I have even more PCI cards and brackets, including some hard drives, and some NVIDIA Tesla cards to measure. And over here, I got some more stuff. So this is a 1U case that I've used before for a long time, so I can measure how they did things if I want to. I like this PCI bracket. It's pretty simple, so I might copy it. Audio. Yeah, I think it's just because I'm moving. It's a really directional mic, and if I get out of shot, it tends to stop working. Also got this beast, which I'm sure you've seen on my channel before, in use. It is no longer in use. Video on why it's no longer in use comes out next week. But we can measure the half-height PCI slots on this guy too. Audio is clipping. It looks okay here. I'll turn it down a little bit, I guess. Negative 10. Seem better? I think what you might be seeing is that I have a shotgun mic, and I'm set to the shotgun mic, right? Yeah, I'm set to the shotgun mic. Okay. Yeah, so actually, so I'll describe my plan a little bit. So I'm going to put this down. Okay, back here. So we're at kind of an odd angle, but I have another camera for you guys over here. So let's go to this one. Okay. So my basic thought is to go to send, cut, send, and have them laser cut it for me. So I'm going to do CAD in Onshape, which means all of you guys can follow my CAD, and additional audio input on that scene. Huh. Yeah, I see what you mean. Maybe I do have an additional audio input. Let's see. You know, I think I only have one audio input on that scene. Okay, I'll keep an eye on the audio. Should be, yeah, this one, this scene. Basically, this is Onshape. This is where we do CAD. And I have all the material properties open from send, cut, send. and Zencut Send themselves. So they make laser cut parts. Before you ask, yes, I did look at ProtoCase, and it was much more expensive, I think. So we will see. Also, we could open any more references we might need, like an ATX pattern standard or something like that. So yeah, so let's get going. Someone says you need to check out Mods. Limited motherboard trays. Okay. So let's create a document. To home lab case. There. Now we have a case. So for inspiration, I kind of want it to look like this. Not the trash can. The, like this. This looks really beautiful to me. I know it's wildly expensive, but just I like the design of this. So I want the front of my server to be aluminum, like brushed aluminum. Nice looking brushed aluminum. So yeah, it is a gorgeous case. You're right. I'm not going to buy one and turn it into a low-end server. That would cost me more than the rest of the server combined. But we can make one out of aluminum. So our options here are 6061 or 5052. I believe 5052 is cheaper. Also, we could make it out of copper if we want to pay a ton of money. AR500 tool steel. Yeah, most of the case, I think I'm going to make it out of mild steel. Could make it out of stainless steel. So, yeah, stainless. Motherboard inserts and stuff I could make out of Delrin, or I could use riv nuts they make. And yeah, so most of the case, yeah, so 5052 can be more easily bent. Zencut Send won't bend 6061 at all, but that doesn't mean it can't be bent. It just means that they won't do it. But if they do it, yeah, so they have these standoffs. Let me find their, they have a page here. Hardware insertion, on all the hardware they offer. And they will do this for like, yeah, so $9 plus like 50 cents or something per hardware. It's not that expensive if I'm doing a lot of them. So I would do these, and these are like a press-in standoff. Oh, I have to view the hardware catalog. Standoffs. So I could do, I think a motherboard tray is usually like an 8. No, it's not an 8. It's probably number 6. So I would use something like this. Flush standoff, 632, 3/8 inch. Could even add a 1/4 inch. Maybe this guy. Yeah, so basically this is a threaded insert, and it gets pressed in. So you cut a hole in the sheet metal, and then a tool comes in and presses this in, and then you've got a standoff. And I believe it's threaded all the way through. Well, it's not threaded all the way through, so it's D. Yeah, so basically it's a press-in tool, and it's pressed in, and then it's part of the case. This is how, like, commercial motherboard trays would be made. What is depth? So there's D here. Thread size. Okay, so this can do 048 and thicker, and aluminum 040 and thicker. They also have press-in nuts like this. So these get pressed in from the back side. So you have a hole on the top, you have a flat surface, then the nut gets pressed in from the back side and you can screw into it. Yeah, so here are the colors they offer. Actually, I was thinking of just doing brushed aluminum and not painting it theme color. I could paint it, they can do anodizing. Where is their anodizing page? They have some colors they can do, and I think their gold is relatively close. Yeah, so this gold, it's not exactly my color, but it would probably still look really good. So I could do a gold anodized brushed aluminum. Or I could just do a bare brushed aluminum. Aluminum should hold up pretty well. It's aluminum. Yeah, I don't really want to hand paint anything because I'm a terrible hand artist. So not going to not gonna do that. So yeah, let's brushed will look good, I agree. And I don't want to put fans right on the front. I'm going to put a layer in, like, so the front panel And I'll put a second panel in for the fan so the front can have like a really cool design. Because like 45 drives has that whole fan spiral on the front. That's like clearly where the fans are. And I want it to look more like this. It clearly doesn't have the fans. I was only going to make one to start, and if I like it, I will make... Oh, how many you? Sorry, I thought you said how many are you making? Yeah, 2U. Because that is what the poll said, 2U. So let's look at a sketch. Nope, you're going to be on front. Front. Okay. So how big should my... Come on, do your thing. Moving on. It's just worked. Oh, it's on the right plane. Okay. You're going to be in front plane. That's better. So how big is a rack unit? I'm just going to go measure the one that I have. Come back to you. So first we're going to pin this into the origin. And I know the height is going to be 88 mils. We'll dimension the height. One U, 2.5. No, it's like 1.875 inches. 95 mils. That seems too big to me. Wikipedia. What does Wikipedia say? Rack unit. One and 3/4, so 1.75, so 44.45 mils. So I have 89 mils, basically. So 88 mils. 88 is my height, and my width. I'm not sure exactly how wide it should be because it's 19 inches, but that's like a nominal distance. So take the metric tape measure and go measure one. 48 mils. 48.5 mils. Okay, I measured two. One was 48 mils, one was 48.5. So we'll go the bigger dimension. Oh, that was centimeters, so 485 centimeters or millimeters. So that's basically the space I have to work in. And we're going to turn that. Actually, this one's just going to be a plate, I think. So thinking of construction methods, I guess I could pull the other one over here. Basically, I wish I could draw on my screen. Making some merch. I've thought about it. I don't have a good logo to make merch from. There's a local company that does t-shirts that could do them for me easily, that I am friends with, in Pontiac, like downtown Pontiac. So I could. Yeah. I've used them for a bunch of other things. So yeah, I've been thinking about it. I know what their price list is and volumes and things like that. Then I'd have to do a web store, or I'd have to sell them on Ko-fi, one of those two. Maybe I should sell these cases, and people can buy them with whatever color they want, and I'll assemble them for them and ship them. That seems like a lot of shipping. Yeah, Pontiac, Michigan. I lived in Flint for a long time. I lived in Flint through the entire Flint water crisis. Now I don't live in Flint anymore, but yeah, I'm not that far from Pontiac. Okay, so here is my front face. What are my dimensions? Wikipedia, help me out here. Yeah, so what I'm thinking about doing is making making a bottom tray on the case that folds up and then wraps around the top, so it looks like this. And then that would be one piece, and I would add all the motherboard standoff mounts and the hard drive standoff mounts all into that one piece. That would be a relatively complicated piece, and I would probably either not anodize at all, or let's see, what colors can they do? Can you anodize? Oh, you can just look over here at 1018 mild steel. What can you do to mild steel? You can do no powder coating and no anodizing. Okay, so I guess we're not going to make it out of 1018. I could make it out of stainless, and then it just won't rust. Sun purple. Yeah, purple racks are beautiful. I really like the SGI blue stuff. The speckled blue, plastic. Mild. I thought mild could do hardware. I guess I have to find another mild. Resources. Laser cutting. Materials available for laser cutting. Mild steel. Oh, mild could do more than this. Bending, plating, powder coating, tapping. Down here is... Oh, I see. It's the thickness that's the problem. I need to go thicker. Go 48. Then we get hardware, powder coating, plating. Okay. That was my problem. So mixing materials is bad if the materials are bare. In this case, at least one of them is going to be powder coated, so the metals won't actually be touching each other. So if I go to powder coating, they have many colors. So basically, I would like make a... Currently, I'm not shopping for anything. I'm shopping for how to make parts laser cut from Sencut Send. Yeah, so I'd make a motherboard tray unit that goes the full depth. See in camera view, full depth, and that would have all of the motherboard standoffs, the standoffs for the drives, and all that kind of thing. And then I have a back panel that has the I/O cutout, the power supply cutout, and the low profile PCI brackets. And then the front panel would be aluminum, and the top panel would also be steel. So I have 3 pieces of steel, 1 piece of aluminum. Yeah. So the front aluminum, I think I will try thick. Yeah, 250. No, not 250. Maybe 080. Probably a few $100. I remember Linus Tech Tips mentioned that he was spending like $1,700 on those stupid 1U gaming PCs, but yeah, I'm not going to spend that much. I did some pricing of basic bent parts and stuff, and I went through their thing, and I think it'll end up costing like, I don't know, 250 or something for the parts. I need fasteners too, maybe a bit more. Not outrageous. More than you'd cost, I mean, quite a bit more than you would spend buying a case like from China or something, but it'll look nice. Oh, the name Appleard, it came from when I created my first account with Google in 2005. I wanted to just be APAL, but that was too short, so I had to add more letters on the end. Okay, so we can do 080, thick aluminum. Yeah, I know, he did a ton of bodge, it was awful. I was actually thinking I could turn this case into a, because my plant, so he has a full depth rack, and I don't have a full depth rack. I have a 2-post rack, which is like a network rack. And the downside of 2-post network racks is that they don't have the back post to attach rails to. So I can only front mount my servers on the front, and they can only be about 22, 23 inches deep before they hit the wall. So I think I'm planning on going about 20 here. I'm going to measure and see how big my reference case is. Okay, so my reference case was 40 centimeters deep. I think I can go 50 centimeters. Yeah, it's not ideal to have a 2-post rack, but if your chassis is really short and it's not like super long, it'll survive. So I just need to make sure it's well built enough. Fix that soon. Yeah. So I thought about making a video where I water cool a server in this 2U small factor and talk about how much cheaper it is than Linus's. But I've never done water cooling before, and I don't want to do that right now. Okay, so we are going to make the front panel out of 080 aluminum because it's beautiful. So in that case, we are going to make you sheet metal. Yes, do sheet metal. Thicken. You're going to be, what thickness is 080 aluminum in metric? 2 mil. 2.03 mil, bend radius of around 60, 61. It has no bend radius. So I'll take the one from 50, 52. Not properties. .9 mil. 2.9 mil, material, relief. Yes, I like you. Okay. We now have a panel. Yeah, mounted as a shelf for support. I actually have a... It's going to sound awful. I have a UPS on the bottom of my rack that kind of holds up the stuff above it. And then all the switches go down from the top, and the servers go up from the bottom, and then in the middle there's just a gap. And I used to just set my cable modem on the gap, on the server. But that got really irritating, so I got a proper shelf. Cable modems, like, it's the worst. Yeah, the UPS was designed for two-post network racks. So I looked at the hardware and I'm like, there's no way this supports that huge battery overhang, but it does. Okay, so now I'm going to round my corners. Oop, that's not a... I want to make you... Come on. Where's my tool? Fillet. Yeah, you. Yeah, you. We want to make this beautiful, like Applewood. 2. 5 mil fillets. Let's go bigger. I guess 5 mil's fine. 3. 4. Okay. There is, okay, so now we need some holes. Could use like the hole pattern tool, or I could just sketch them. So we need some mounting holes right about here. Yeah, so usually I use FreeCAD when I do 3D printing because it's open source, but I've been using Onshape now because the robotics kids use it and I have to learn it. So, yeah, Onshape. I have an educational account, and aside from getting an email every week about like the latest educational Onshape news, it's a pretty good deal. Back to this monster. Yep. You can't see it on camera, but this monster is my old 2950s. We're using them as like just as shelves, or we're using them as switches too. I think Wikipedia tells me how far apart the holes should be. So holes, it says, should be... This seems off. Oh no, that seems right. Yeah, so 3 holes in a 1U space, and they're spaced 5/8 apart. So if I'm in a 2U, I should be picking up this hole and that hole, which is a 1, 2, 3 hole gap, which would be, oh God, math. What robotics do I do? I do Vex robotics, and Vex IQ and VRC. And I have like 70 kids on my teams. It's wild. Wild. Math. So I'm going to do 3 holes apart, which would be 0.625 times 3 into metric. 47.625 millimeters. So your dimension here to here is 47.625 metrics. You're going to be the same. Let's see, so my total height is 80 something. I need to split the difference here. So what would this dimension here be? So that's 88. And we want to do vertical. 88 minus 47.63 over 2. And then we'll just set u equal to, I'll go in this dimension, please. Yeah, 0. Okay, so how far apart are you? Wikipedia. What is the width? Pitch of the holes, not like the 19-inch. I'll just measure it. In real life. $47. My current one has slots. I need to make slots. Maybe I should pattern this after all. Yeah, we're going to pattern this. We're going to delete the... Oh, I delete this. Okay. So we're going to make a single sketch. And we're going to make a slot. Is there like a slot tool, you know, in shape? Please. Okay, we'll make 2 circles then. Connect them with lines. Okay, so you need to be, it's like 28 or 48 mils apart. So you're 88 mils minus 48 mils over 2. That's your height. This distance here, measure with tape measure. .47 is our outer, centimeters is our outer. Starting at like 48 and a half, I think, or 48. I don't even remember what I picked. What did I pick as your dimension? Ah, 485, okay. Let's go back here. So what's your dimension here going to be? You're going to be 485 minus 470 over 2. There we go. And then you're going to be, oops. Measuring tape. 46 and a half. 462. Oh, minus 470 minus 462 over 2. Yeah, it's tiny. And you need to be horizontal, U to U. Nope, does not like that. Yes, we'll dimension U in this dimension. How big are rack holes? Number 12. Jesus. M6. Okay. Pretty sure my rack screws are massive. They are the universal square type. So an M6 would be a 6 mil. So you need to be bigger than 6 mil. So you need to be like 6.25 mil. I think. Yeah. And you need to be equal to whatever, I'll just retype it. And you guys need to be tangent. Okay, you are fully constrained. Now we can delete the excess. How does one do that? Pierce, normal, multi-point. Trim. Okay, I now have a slot for my mounting holes. So now we will extrude the slot. And yes, there's the slot, and we are going to remove. We're going to do through all of it, out of here. Linear pattern for you. Pick you, and I want to pattern you. Entities to pattern. Extrude. Select parts to pattern. Huh. Maybe I don't know how to, as well as I thought I did, how to unshape. So I want to take you, is this hole, not that. And your pattern. Feature pattern. Oh, there we go. Okay. Feature extrude. Direction. We're going to go with Z. How do I pick Z? Feature to pattern. Extrude. Direction to pattern. No. And to pattern you on the face. Why are you having such a hard time? That looks right. Okay. In that dimension, and you need to be 48 mils. Boom. Actually, it's not 48. It's, God. 47.625. Okay, now we got you. Now we're going to take you two, and we're going to pattern you. Please. Pattern you. Feature pattern. You and direction is going to be this way. And how far apart are you? Measuring tape. .66. .466. Finally. Have a face. This is our faceplate. Okay, so what pattern do we want to put on the face? Our inspiration is the beautiful Mac Pro. So I'm going to sketch a hole and do a bunch of holes. Nope, we're not going to extrude. We're going to sketch. Cube. And we are going to make a hole. How big should it be? 33 mils, that's a bit big. How about 16? Yeah, let's do that. Okay, you're going to be the first hole. Oops, you need to come from here to here dimension. Maybe a little bit closer to the edge. 60 mils. Yeah, that seems reasonable. I'm going to have, I don't know, 3 rows of you, so we need to fit, come on. Sketch lines in the middle. Yeah, you're right, it would be. That might make the rest of this faster, too. We'll see. 24 mils, 20 mils. You know what, 88. Maybe I should do 24 for you. 14. It's too close to the bottom. 18. That looks good. I'm not like a SuperCAD expert, but I've done this like in the past. Remove. Through all. What? What did I do wrong? How are you? There we go. I still did it wrong. Okay, have a sketch. Extrude the sketch. Select the circle. Remove the circle. Through all. Yeah, you're probably right. It probably would have been easier if I was more of an expert. We're going to do a feature pattern of the extrude. We're going to go along this axis. Oops, no. Direction. This way. You're going to go that way. No, 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 no. Just the extrude. Okay. There we go. 10. 10 holes. No, we're not 1 or 2. 10. 10 holes. More. 15 holes. More. 17 holes. Too many. 15. 14? 15. 16? Oh god. Nope, nope, nope. Is that like relatively even? Yeah, I think so. Oh, centered. 25 mil. How about we do 23 mil? The tighter spacing. Let's look at our reference. Those are really tight. 22 mil. Not 20 of you? Nope. 18 of you. Yes. Okay. Now can I take my pattern and pattern that? Feature pattern. You guys are going to go in this direction. We're going to be offset by 5 mils. Second direction. Oh, that would make a symmetrical grid. I want an asymmetrical grid. Let's rethink our life choices a bit. Yeah, so maybe I need another one that's offset. You, sketch 4. Come back. How big did I make you? 22. I think I made you 20. Made you 16. Okay. 16 mil, we decided. 15 mil. There to 38. 36 looks reasonable. 40. Meh. 50. Meh. 52. 48. Let's try that. Oops, nope. Stop. To do you and remove through all. Okay. Now I have two holes. Now I can pattern these two holes separately to make my pattern. You are a feature pattern, and your feature is extrude 2. And the direction is going to be that way. Direction. That way. Reversed. Actually, if I do it this way, it'll let me know if they're lined up. That looks pretty lined up to me. I'm pleased. Okay. Now I need to make you go all the way across. I think I need 16 of you. 16. Might be too many. I guess we'll find out. And now next we have to pattern the next one. Spending so much time on this beautiful front panel before I even make the rest of the case. Features to pattern. Extrude 3. Direction. Edge. Flip. You're also going to get 16. Yes, I like that. Now we're going to pattern you up. So we're going to pattern feature extrude 2 and linear pattern 3. Direction is going to be up. Nope. Direction is going to be up. And you're going to be in the other direction. 25 is too low. How about 30? I don't remember what dimensions I typed. That doesn't look right. That looks too tall. How about 28? Looks a little bit off to me. Am I ever going to notice? Probably not. I think 3 instances. Yeah, I'm a little bit off. Okay, so time to do some shifting of my initial. You need to shift down like 2 mils. Okay. Now, does that make you look more symmetrical top to bottom? Yes. And you need to shift down by 2 mils because I shifted the other one by 2 mils, so 30 mils. Do we look like we have the same gap here and here and here and here? I'd say, okay. One more linear pattern. I'm just going to do through holes. My actual plan to make this look better than the cheese grater was to have 2 layers. So the first layer would hold the through holes, and the second layer would hold the fans. So I could put an offset set of through holes to make it kind of look like a cheese grater without having to actually make a cheese grater. Because making a cheese grater is a lot more expensive than making through holes. But if I have my fan piece behind it that mostly looks like an offset of holes, I think it'll look pretty good. So now we need to pattern the middle row. Up. So we're going to feature pattern. We're going to pattern extrude 3 and linear pattern 4. And direction is going to be that direction. You're going to go up. I think they are 20 mils. No, that's not right. 26. 28. That looks better. Okay. So now I have something with good airflow that resembles a Mac Pro. The other option I have is to just put a, just acknowledge that it's not going to be as nice looking as the beautiful cheese grater here. And just have a big bunch of through holes. Okay, so we have a front panel. And I should probably rename this to front panel. So now if I go back to my folder, I can start making a tray for motherboard. Come on, Onshape. Actually, can I do multiple bodies? Some programs make you make like a separate part file for each. Yeah, you're right. But I was thinking that the macro has handles here, and I either need space for those or I need space to bolt stuff through over here. So I think I'm going to have some bolts on this side that will hold the case together. Now let's measure. Do I have a measuring tool? How do I measure? U to U. Min distance, 40 mil. U to U. Oops. U to U. Min distance, 42 mil. Yeah, you're off by, I'm off by 2 mils. That's pretty darn good for just guessing. How about top to bottom? U to U, 8 mils. U to U, 8 mils. Okay. I think it just looks off because the pattern doesn't stick out on this side. So I could shift the whole pattern. This way. To make it so that this one has, these two rows have one more in them. Because currently they all have the same number of holes. Which means there's 2 that stick out on this side and 3 that stick out on this side. I don't know. I like the look. I'm going to keep the cheese grater. Exactly how it is. Okay, so now we need to take you and features. The left one looks better. So I need one less hole on this side. I need to change the spacing. I'm going to leave it. Create document. Motherboard tray. Okay. Now we get to the fun part, laying everything out. So this will be somewhat based on like what I have space for, because I think I have space to go 50 centimeters. So your sketch is the top plane. So we're gonna go here. I'm just gonna draw a rectangle, and that's gonna be the inside dimension of the case. And this will form the motherboard tray. You are currently 40. You are currently 43.5. Okay, so we're going to be 430 wide. So this is the inner dimension, because then the flange goes out to mount to the rack. And this will be the depth. Now the question is, how deep do I go? So I have a case that is 40 centimeters deep that does fit my rack. I think I could go a little bit more, but I don't know how much more I need to go. Yeah, so the symmetry that I like is that it seems like if I put a bunch of them next to each other, they'd kind of look like they would nest in. And that seems appealing to me. I also don't want to go redo all the dimensions. So 489 would be too deep. How about we go 420 deep? There we go. Perfect. So here is our motherboard tray. We're going to turn it into, yes, 420. And then we're going to turn that sketch into a sheet metal model. Please thicken. And we are going to use mild steel. My options for mild steel are 030, 048. 048 is probably thicker than I need. That is 1.22 mil, so 1.125 mil. I really like 1 mil, but it's probably strong enough. Certainly strong enough. So this one can get press fit hardware, powder coating and plating, and bending. I don't get countersinks. It's too thin to tap and countersink, and that's fine. Okay, I'm not going to countersink my motherboard tray. Let's see. So you are sheet metal 1.22 mil. 1.22 mil bend radius. 1.4. 0.87. Bend deduction. That's the one I need. 2.18. Material, K factor, 0.38. What are you mad about? Come on. Oh. That's a big face. Okay. There we go. We've motherboard tray. Congrats. So I need to think about how big my motherboard is going to be. So if I look at Wikipedia, ATX. ATX form factor. I think they have dimensions here. So I'm doing micro ATX because micro ATX motherboards used are really cheap. But I also want to be able to fit full-size ATX. So that's going to be my assumption. So 305 by 244. So let's go make a sketch that is 305 by 244. And that is going to be the motherboard. Actually, what dimension's what? Okay, 305 is height. 244 is depth. Okay. You are 244. Oh god. 45? Is that? 305. Oh god. Okay. 305. Okay. So that is a motherboard. So I can move this around. And I'm just going to leave it there. It's just going to sit there. Give me an idea of where a motherboard is going to go. That is massive. No wonder I'm using... Yeah, okay. And maybe we won't fit ATX. Micro, 244 by 244. Yes, I know this will be more expensive than the motherboard than Retro Electronics. Part of the other thing is I already have a micro ATX motherboard. And I already have a second micro ATX motherboard on the way. And basically, yeah, I know the case is going to be more expensive than the rest of the electronics. The CPU might be more expensive than the case. The GPU probably definitely would be if I put a GPU in. Goddamn crypto miners. Actually, thanks to the crypto miners, we can now get used GPUs from a couple generations old that had a hard life. So there's the micro ATX. Also, I mean, so I'm thinking of like what I/O I need. And so I need a CPU, obviously, and I need RAM, obviously. I want a 10 or 25 gig card. So those can do, a 10 gig card can use like a PCIe lane off the chipset. Even like a PCIe Gen 2, it can do, I think Gen 2 by 4 is fast enough for a single 10 gig. And Gen 2 by 8 is fast enough for a double 10 gig or a 25 gig, single 25 gig. So I don't need two graphics card. So I'm planning on putting a graphics card in these. I currently have, digging them out here, the two NVIDIA Tesla P4s. I bought these back when Craft Computing did a video on them, and they were awesome. What's going on here? YouTube is stuttering. Happy again, YouTube? Stream is healthy. I don't know why the stream is unhappy. OBS says it's fine. Yeah, so I have NVIDIA Tesla P4s. I have two of them. And I was planning on doing a vGPU project where, because a single Tesla P4 is the same die as the 1080, but it's clocked lower and uses less power. Okay, bye, Mike. Okay, it's back to normal. That's good. Okay. Yeah, so the Tesla P4 uses the same die as the 1080, but it's has a lower power limit, and it's slot powered, so it can't go above 75 watts. So it's not quite as powerful, but roughly it's equivalent to like the computational power of like at least a 1060 and a half. And my thought was when I bought these that the GTX 1060, my thought was that the P4 could be split into like something between two 1050s and two 1060s, which would mean that if the 1060 is the most popular card on Steam, and it was back a year ago when I bought these, that if I had two P4s, split them each two ways, so that'd be two 4 gig vGPUs, I could do a 4 gamer 1080p split screen. That was my plan. So I was going to take my Threadripper that died, that had a buttload of PCIe lanes, and do the Radeon card for the display, and I was going to do a 4K like TV, and then quad 1080p gaming sessions, each on a quarter of the screen. So my thought was I would have 4 Windows VMs running games, and they would each get half of a Tesla card. And then Looking Glass would take the half the Tesla card's 1080p output and composite it in 4K, so we had 4 1080p gaming sessions. So you could do local multiplayer using games designed for internet multiplayer. Then you could have like a LAN party in a box. That was my thought. But I didn't build it yet. So I'm going to take the Teslas instead, and I'm going to put them in the server so they can do transcoding for me. Or I could build a server later. I don't know. So that was the thought. So basically, I need 2 PCIe devices in each server. One is the networking card, and one second is the graphics card. And then, what else? Yeah, so the motherboard will have 2 M.2s, I think, and 4 SATA. That's what I have right now. And so the plan was to just hook all of my drives up to the internal SATA on the motherboard, which means I can't use SAS drives. But I'm only planning, I mean, I know I asked the question and people said they wanted up to 4 hard drives or up to 8 SSDs. And so my plan was essentially to build this thing to fit 4 SSDs, like 2.5 inch, and wire those straight to the 4 SATA ports on the motherboard. And that would let me build a ZFS RAID Z1, or I could use it as 4 SFOSDs in a cluster. But I think 4 2.5 inch drives is reasonable for most people now. I don't think the 3.5 inch drives have a ton of life left in them for like daily storage. For archival storage, they're still great. Or for backup storage, I mean, like your second tier, the SAS 3.5 inch drives are awesome because you're not as concerned with speed. Yeah, latency. So latency with Looking Glass is not bad. So Looking Glass does a frame buffer copy straight out of the GPU. So it doesn't capture like the HDMI. So as soon as the frame is rendered, it takes that frame buffer and it copies it into the memory of the host from the virtual machine. So the virtual machine has its GPU and it's rendering on the GPU. And then as soon as the rendering is done and the frame is ready, it does a mem copy out of GPU RAM into host RAM. that's shared by Proxmox, where it can then take that and composite it on its own Radeon card. So Wendell did some videos on this, I don't know, maybe 2 or 3 years ago. Not on vGPU, but on Looking Glass and the mem copy, the direct memory copy, and it's actually quite good. He was getting less than a frame of latency. Oh, it's 11 o'clock on a Saturday, or sorry, 1 o'clock on a Saturday. It's the monthly tornado alert test. Yeah, so you can fit a lot of 2.5 inches. I don't plan on using that many drives. Most of my servers don't have that many drives on them. Like, I know people are like, wait for the test to finish. Give me a sec. Yeah, so don't get too hyped about the vGPU video because I don't have enough hardware to do it right now. I was going to use my desktop Threadripper, which had enough PCIe lanes to do it and enough cores. But my new desktop only has 6 cores, and they're good cores, but it's probably not going to be a great gaming experience with 4 people. So I have a new CPU coming that's an 8-core Ryzen. It's a Ryzen 3000. That could do it. So you'd get 2 cores and 4 threads per gamer. And if we played like a not so intense game, that'd probably be fine. Okay, so these guys use, oh my god, Siren test. Yeah, a few large SSDs. So currently on my storage server, and I just recently, like just a few days ago, oh my god, this is just so loud here. I'm waiting for the siren to finish before I keep talking. I'm gonna go get an SSD. Yeah, so my siren test is at 1 p.m. on the first Saturday of the month, which is right now. And it's done. Also, the fire station that has the siren physically located at is not very far from me. So it is very loud. So anyway, I got 2 SSDs. This is a SanDisk 3.84 terabyte NVMe, so it's U.2, that I bought used. I think this was about $200. I don't remember. Anyway, I wanted to test the performance of U.2 to see if the mic doesn't pick it up at all. I sure hear it in my room. So I guess my noise canceling on my mic is good. So I got this SanDisk 3.8 terabyte NVMe, which is U.2, to test and see if buying these used was better than buying the cheapest hard drive on, or the cheapest SSD on Amazon used. Or not new, sorry, not used. So I went on Amazon and I filtered by 2 terabytes, so I don't want anything less than 2 terabyte, for SATA 2.5 inch, and there were just so many no-name brands, so I bought one. And we're going to see if it even has 2 terabytes of space, but that was my plan, was to buy a bunch of these. They come in all kinds of colors too, which is kind of fun. Not that anyone's ever going to see them, but relatively cheap. If I build a ZFS pool out of them, I'm probably not going to be terribly concerned with their individual reliability as long as they don't all fail at the same time. So that's why I'll just buy a bunch of different brands and mix them up. Maybe I'll throw in a good one too, just to be safe. So So that was essentially my plan, was to use these little guys. But I also bought the bigger one just to see if I liked it better. Okay, yeah. So anyway, drives. We're going to get to those in a bit. So back to my CAD. So if I open my sketch, so this is where this is the motherboard. So now I need to make all of the mounting holes for a micro ATX motherboard, which thankfully ProtoCase, who I'm not using to make my case because they were too expensive, has dimensions for me. So they use a 3/8 PEM nut, which is the same that Senka Send will have. And they're using a 632, they're using a number 632 fastener. Somewhere down here they had ATX board, micro ATX board. There we go. Okay. That's a PCI card. There we go. Okay. So holes are, they're doing 3.81 mil holes. Keep out area A, keep out area. So where are they referencing their dimensions from? So they're referencing from this corner down here. No. They're referencing from this corner down here. Okay, so that will be my reference. So I need 1, 2, 3, 4, 5. That's a lot of mounting holes. Let me look at the motherboard I have. D450. I think it's this one. Yeah, this looks like the board. So it has a hole 1. Do you have like a front? Yeah, there we go. So this is the top. So 1 mounting hole, 2 mounting hole, 3 mounting hole, 4, 5, 6, 7, 8, 9. So they skipped out on a hole here, I think. And this particular hole here they skipped out. Because that one down there doesn't count because it's not plated. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they skipped out on the bottom one here. Or did they? Yeah, they skipped out on the middle one here. Okay, so I need those holes. So they are 3.81 mils. So 1, 2, 3, 4, 5, 6, 7, 8. And we're referencing from this corner in this diagram. 3.81. 3.81. 3.81. Oh, this is the making a cutout, so I don't care what hole the motherboard has. I need to know what the fastener needs, which is services. Hardware insertion. Standoffs. I have to do the catalog first. Standoffs. Number 632 by 375. How big of a hole do you want? Hole size in sheet, 215. What is that in the metric system? 5.461. Okay. Just forego the rack. I like the rack. .461. 5.461. Okay, so now I've got holes here. Where are your dimensions? So you are 33.02 from the bottom. .302, and next one is 165.10. And last hole is at 237.49. Okay, so now I have the holes, and they are at 237.49 from the other dimension. So these three holes are good. Next three holes, you are at 10.16. And you are at the 165 again. We'll make you go this way. And last one is also at the 237. And what is your height? Yeah, you're all the 165 as well. You are at, in this dimension, 80. 80.01. You're all at 80. No, 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 no. You, there. Okay, so those holes are lined up. Last two holes. So you're also at the 10.16. So you can, yep. And you are at, also at the 165. Height-wise, we've got one at 34.29. And the last one is this hole at 13.97. Okay, that is the motherboard tray for an ITX, or not an ITX, a micro ATX board. So now where do we want to locate it in space? So the cards stick out the back. So, nope, 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 go back. I liked that picture. Top view. Okay, so at 0 is the board edge. So at 1 mil is where PCIe brackets want to start sitting at. So I'm going to put the board edge 1.14 mils from the edge of my case, which would be U to U. Right there. And where do I want to put the board edge in that dimension? Give it some space for wiring. How much space do you need for wiring? How about a centimeter? 10 mils. Okay, fully constrained. So now all of these holes need to get, drilled. One, two, three, 4, 7, 8. We're going to go all the way through. Okay, motherboard is done. So now we got to figure out where we're going to mount our drives and our fans. So my thought was to build, like, I could either 3D print this, or I could build a sheet metal bracket that holds both the drives and the fans. Like if a drive is like this, and I hold it on end, I could build like a little cup that goes around the back, and then the fan bolts into the front of it, and there's a stack of drives in it. And then I could put like 2 of those in the front. And that would hold all my drives and all my fans. I'm not going to use like a server, like passive heatsink for the CPU. I'm just going to use a box cooler. Literally the AMD box cooler. Maybe I'll get a nicer one, but yeah. So there's my motherboard holes. Next I need some, well, I guess I could make the rest of it first. Let's think about this. So I'm going to make this thing bend up and around, and then I'm going to screw the top in, I think. Thinking about this. So I go back to my front plate. Where do I want to attach to? Because I don't want to put too many screws in the front plate because that would look ugly. But I could put like some big fat flatheads and countersink them. That would look nice. What hardware do I have? And nuts. Press nuts. M6. Big fat M6. Maybe M5. Yeah, so printing would be more of a temporary thing. Sheet metal would be like rock solid. The other thing is I kind of want to mount these sideways. So I could just like only hold them in by 2 screws and just kind of overhang them. Which the other option I could have is I could build like a flange that goes on each side and then has a flange to screw down. And I could just put the fan in the side. Because I kind of want to mount these, going back to my cat, I kind of want to mount them in this orientation. With the cables coming out the side, so I can route the cables like this instead of having the cables come out the back. That's the thought. I could just build separate brackets for the drives too, or I could hold the drives in with double-sided tape because they're like super cheap Amazon SSDs. I know. Or I could just put some PEM nuts in the design and then make the option to use either a hard drive or a SSD caddy and make 2 different versions of the caddy that bolts onto the same PEM nuts in the motherboard tray. But in any case, I was going to make a baffle that goes across the front just behind the beautiful holy aluminum sheet. And the baffle would have the fan in it and the filters, so no air could get through if it didn't go through the fan. So then the air would have to go out the back. That was the thought. So anyway, let's make some flanges. Here and here. You 2. Okay, so you need to be, so you're going to be an inner bend. You are blind, and you are going to be 88 mils. So that is now the full height. I think I should decrease that by the material thickness of the top because I'm going to put an inner flange on this as well. So material thickness is going to be using 1.2 mil. 88 mils is my total, so I'm going to bring that down to 86 mils. We're going at 85 because I also have the material thickness of the bottom. Okay, there we go. Then I'm going to put another flange here. And this is going to hold the PEM nuts that secure the top of the case. So you can be, 20 mils. How much space do the PEM nuts need? If I use an M4 PEM nut to hold the whole thing together, that's a 4 mil. Think about life for a second. Do I like a 4 mil or do I like a 5 mil? I mean, structurally, an M4 is perfectly fine, but Yep, sheet thickness, okay. So you need... I use both unit systems interchangeably. I convert units in my head all the time. But I'm going to be buying fasteners on McMaster, so I can just pick whatever sizes I want. And I already have to buy number 6s for the motherboard, because the motherboard needs 632. So I'm thinking of how long this flange has to be, because I'm going to put some PEM nuts down the flange to screw the lid of the case into the motherboard tray. So I'm looking at the specs for these M4 PEM nuts, and I'm wondering what 378. So I'm wondering what my clearance to the edge needs to be. There, center line to edge. Okay, so I'm good. 272. So you're going to be a 20 mil flange. I'm going to put like 4 or 6 PEM nuts here for an M6. Oh shit! Then I'm going to have the button head. I don't like this as much anymore. What other hardware do we have? Hardware. Studs. No, that's not going to help. Standoff's not going to help. Yeah, I don't know. What kind of dimension do I have for this? M4 flathead screws. Metric alloy, metric stainless. So it must use a Torx. T20. T20 is kind of big. What motherboard form factor? Micro ATX. Maybe go M3. M4 is kind of big. I want to use... M4. Fastener type, flat, drive style, Torx, head diameter. Okay, so you're going to have a 8 mil head diameter, and your countersink is 90 degrees. So how deep is that? Because the thing I'm worried about is I'm using 1 mil thick steel for the top of the case. And if the screw head sticks up, that takes away from my total thickness, because I don't want to hit the next thing in the rack unit. So maybe instead of the flange flipping over, maybe the flange should be part of the other piece. So I'm going to delete those flanges. And instead, I'm going to put the holes on this side and then make the top flange down. I could flathead, but I'm only using a 1 mil thick piece of steel, or even less than 1 mil. Maybe I set it at 1 mil. Okay. What is that in inches? 0.048. That's what I'm using for the motherboard chassis and for the so the motherboard case, which is the bottom, and also for the lid. They're going to be 0.48 steel, and I'm going to paint them black, or just leave them. I don't know. Depending on how much it costs. So 1.22 mil. So I should lower these. Yeah, I guess we're okay. So now here, we're going to sketch on you. And we're going to make some holes for the bolts. And I'm not going to countersink them. I'm just going to use M4 button heads. And I'm going to use 6 of them to hold the lid on, because it's structural. The lid is structural. I'm not going to have any rails on the inside to support the server when the lid's off, because this is supposed to be low cost, well, lowish cost. So you need a 4 mil, so I'll make you like 4.25. Itty bitty, okay. You're also going to be 4.25, because this is a clearance hole. So then I'm going to use a button head through the motherboard case and into the PEM nut that's in the lid. Or I put the PEM nut here and I have the lid wrap around it. Which one of those do I like better? Do I want the lid on the inside or the outside? lid on the outside would be easier to work on. So I should put the lid on the outside. So I need to know how big the PEM nuts are. M4 PEM nuts. So they need a hole that's 212. 538. So there's going to be PEM nuts, and they need to be, so our case is 420. So I'm going to put these, new to you, I'm going to put you 200 apart, I think. Puts it too close to the front. How about 180? And then the center, so I got 420. 420 minus 180 minus 180 over 2. 30. And then from the top, you're going to be, it's going to have a 20 mil flange. So that should be, it's 20 mil outside flange. So I should have this flange end a little bit low to have an undercut for the bend radius of the top surface. So 5 mils is too low. What's your clearance to the edge? Center line to edge, 272. So you need a 7 mil clearance to the end. So I'm going to put you at 9 mils. And then I'm going to take another mil off this flange. I already took some mils off. I'm going to take one more. Sheet metal thickness, 48 thou, which is 1.22 mil. Oh, and yeah, so your holes, you need to become not a sketch, not a figment of sketch. So we're going to remove, we're going to move you, we're going to move you, and one more, and we're going to go through all. Then I'll cut the other side at the same time. Is it enough to sink the PEM nut in it? So if I look at this from the front, so the top lid is going to come over the top and then bend around the outside. So the PEM nut is going to be on this side, and the fastener is going to come in from the outside through the lid and through the then through the wall of the motherboard tray and then into the PEM nut. So that's going to compress the PEM nut. So PEM nut is going to be in compression. It'll be fine. Oh, dimensionally? It says it is. It says minimum distance clear center line to edge, 272, and that's 7 mils, and I'm at 9 mils. So yeah, I have enough space for the PEM nut. So these are going to be PEM standoffs, and those are going to be PEM nuts. And then this should flip up to grab a PEM nut onto the aluminum piece. So this needs to be a flange small enough to put PEM nuts so that I can drive a flathead, because I guess I should use all button heads. So here's our picture of inspiration. They don't have any screws because the flange hides the screws. Unfortunately, I can't do that. So I have to do something that looks as good, which would probably mean getting an M4 M6. So M6 is the size I use for the rack nuts. So that is M6. So thread size 6. And it would be a metric, obviously. And it would be a button head. Ooh, I could do a 12 point. That would look really fancy. But yeah, basically, so I get a button head and it's something that looks nice. So not going to do black out. So you're going to be a button head. You're going to be Torx because everyone hates things that aren't Torx. So that leaves me with stainless or steel. So this is what it looks like, and those are going to be in the slotted holes holding it up. So then I want some more screws that attach the motherboard tray to this piece and the lid to this piece, and then I'm going to flange out the motherboard tray so that it sits behind these slots here and also gets held in by those slots. So for the screws in the middle, do I want to use big stainless M6s? Or should I use like an M4 flathead? Probably use an M4 flathead, shouldn't I? Hello from Bangladesh. So in any case, I'm bending up. Partial flange, so you're going to be 20 mils from the edge. And you're going to be 20 mils from the edge. And you're going to be a 20 mil flange. Okay, there we go. So there is my flange. That's going to have some PEM nuts in it that come through holes here. Yeah, so Torx is what I want to use for all of this. Because I can throw that on the impact driver and crank it down real hard. Not that I want to strip the PEM nut, but... So now I need to think about where the hole will line up with this. So I need some holes in this piece. Oh, also, flanges out here. Flange there. Nope, 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 nope. Flange on this side. You're going the wrong way. There's the right way. There's the right way. Okay, so now I need to make it so that the outer size of this is the same dimension as the piece before. So I should probably just measure that one. So how big are you? So you are 485. And how big was I going to make this one? So you are 430. Okay. So how big should my flanges be now? So 430 is what? Minus the material thickness of this flange. So 430 is what this one was. Can I make an inside? Hold on. Let's check. Are you an inside flange or an outside flange? You're an inner, okay. So that would mean this one is also an inner. So we're coming off that outer surface, and we need to come from 430 to 485. So I need to come 55 mils, so I need to come 27.5 mils on each side. There we go. So this is basically going to sit in front of the rack rail, and it's going to have a slot in it so that this piece can, in its final form, this piece can go in front of it and look beautiful. And that will also give some stiffness to it. Okay, so I'll make those slots later, and I'll make these PEM nut slots later. So that is the motherboard tray, I think. I'll probably have to project stuff later for mounting holes and stuff, but I should figure out how to make assemblies in Onshape, because I still don't know how to do that. Yeah, I haven't done sheet metal design in a while. I am actually a computer engineer, but I hung out with enough mechanical engineers to learn some things. Versions and history. How do I like add a part? So I'm in like part design. Oh, you're a part. Maybe I should have done this all in Oh, assembly. Yeah, that's what I wanted, is assembly. Insert parts. Now, do I have to put you all in the same, like... I put you all in here. This is something I'm not super familiar with about Onshape, is how they do assemblies. Because like I learned Autodesk Inventor, where you had to make all the parts and save them all as a part file. And then you had to go back later and make an assembly. But I know a lot of the newer CAD programs keep it like all together. So should I move like this part into a different part? Probably should fix my part structure here. So yeah, I want to move you to a different copy. I don't know how to do this. Let's look at documentation. Yeah, so I started with other CAD programs where you'd had to create a separate file for every single part. And I know Onshape does it, appears to do it differently, where I can make like a single file that has all of its component parts part of it. Whatever, we'll go to assembly. Insert. Okay, there we go. We added that part. Now we're going to add front. Beautiful. So you guys need to get stuck. Planar mate. Actually, would it be a fastened mate? Pin slot. Does this so Onshape is made by PTC, so they're like the creators of Pro E and stuff. This does not go straight to like the fab house. I have to export this as a DXF to send to Sencut Send. You are stuck. Good. That appears to not have done what I intended. Well, you're parallel. Okay, that's not what I intended. I met you to you. Okay. Come over here. And I want to stick you to you. No, that was bad. Maybe I do want a planar mate. You. It's going to try to stick you. I want you to do it the other way. Nope, nope, nope. Yeah, I like that. Okay. And nope, 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 nope. Does Space Mouse? Yes, it does. I don't have a Space Mouse, though. I have a vertical mouse that I love very much. So this piece should be fully constrained. Oh no, that flange looks awful. It's covering up my beautiful mounting holes. Yeah, I'm gonna have to fix that. That is not acceptable. We cannot cover up the cheese grater holes. Cheese grater holes are special. Stop it. Sorry, my automated blinds are closing themselves because they detected that it was time to close themselves because they're automated. Okay, here's where we are. Have motherboard tray. Yeah, I never used a space mouse, so I didn't, I guess. So I gotta get this to not block my holes. Go back. Can I just like bring you in here? It's really irritating. There, sorry, my automated blinds were automating over and over again because it should be time to close, so they keep trying to close. I don't know what that going on. So how do I make this not? So I could just cut a bunch of holes out of it. Yeah, I don't do enough CAD to use a 3D mouse, I think. So I want to have like, so I'm thinking of like, so like I have a face that's attached to the rack. Coming off of that, I have the server, and it's going to be hung, so it's going to be trying to compress on the bottom and tension on the top. So I'm trying to hold this together in a way that doesn't like peel open. But I also have my beautiful cheese grater holes to think about too. Those are very important. So should I try to fit a little flange in between the cheese grater hole for a fastener? Or should I, since the bottom is going to be a compressive load, should I just not? That is the question. So I think what I want to do is I like project you and you. Yeah, okay. So I'm gonna make like a, could just delete that flange and come back to it. Delete the sketch. Flange 2. What are you mad about? Or did I deleted the wrong things? Come back. You. Okay. You're important. Okay, so flange 3 has moved in front of flange 2, so I can delete flange 2 without losing flange 3. So now the question is, do I do a contour flange? Tab. Something is off here. This is way too big. Oh, I see what's going on. Maybe mount the front with standoff screws. And filter mesh. Yeah, actually, that's a good idea. I like that. The other thing I realized is that I constrained the... If I go out of here into the assembly studio, I need to go back to... Oops. keep opening new tabs. Okay, so I was thinking of adding a filter mesh in front of the fan. So I'm going to use 80 mil fans, and I can probably get like a square 80 mil filter mesh. Then I don't have to have one, but then it'd be really hard to clean. So we're going to go to U. So I constrained this wrong. I left space at the top of my flanges for the top to sit over, and I constrained the cheese grater to the top instead of the bottom, which would be this constraint here. Yes. Planar 2. Okay, now I can delete planar 2. I guess we'll make 2 of those again. So we need to constrain planar mate from the bottom of the motherboard tray to the bottom of this guy. Yeah, okay, so you're there. I gotta constrain the end again. I think this is my origin end. So this is gonna constrain you to you. What did you do? What just happened here? Okay, so you... Oh, what is going on with this? This should be mating... Let's mate those surfaces. So now I need to mate these surfaces. Planar mate. From you to you. Go. Okay, that's better. So now my... Yeah, so I get that. The mesh could be a contrasting color. So I can't make this flange thin enough to sit under these. I could cut out every single one of these. Not a constraint, though. So if I did that, it would mess up the dimensions, because then the flange sits further back, which makes the inside a bit funny. This geometry in this corner here would be a bit odd. I guess it already is a bit odd, but it would be a bit more odd. So how many of these do I have? So an even number or an odd number? 1, 2, 3, 4, 5, 6, 7, 8, 13, 14, 15. I have 16 of these. So I could put one... So I could put a fastener directly in the middle and one off from each end. Then I would have 3 M4 screws that would go in through the aluminum into the plate. So let's go back to you. So I gotta get you into the right document. Messed up my documents and now I don't know how to figure them out. Maybe this will let me fix them. So what I really want is all of my parts in Part Studio to be all in the same document. Maybe I'm doing this wrong. Okay, whatever. I'm going to ignore that for now. I have to make a new version of you. So that you can use the new version here. Update. There we go. Okay, so this is how we got now. So currently the only structure holding stuff together is this flange here, which would take the load, and I don't think it would bend. I could rely on it not bending, I guess. How is my current one held together? So this is the server I'm looking at, how it's been constructed. It looks like they added a gusset in the corner that just goes to make this bend thicker. So there's 3 pieces of metal, one of which is the face, which is bent over and screwed on the bottom. So the face wraps around and screws into the bottom. Except I can't bend the, well, I don't want to bend my face because my face is beautiful. My cheese grater. So then the next option is okay, so then they have a second piece of metal that comes up and out, and that is what I have as well, and they have a gusset. Okay. How about the smaller case? Oh yeah, something I forgot. A lot of these cases have like a screw-on rack mount bracket that is not all that big. It's like, how thick is this bracket here? It's probably, maybe it's steel. Looks like about 2 mil to me. Dial calipers say 85 thou. It's like the thickness I'm using. What thickness is that? Oh, 85. 2 mil, okay. 2.2 mil. So that's the entire thickness of the bracket that holds up this case. It's a 2.2 mil bracket that's screwed in with tiny ass little screws. So like this case is quite rock solid, but these 2 brackets are just screwed on the edge. I don't know, maybe it'll be fine. I mean, there's so much structure down this whole thing. The concern I have is that this corner will try to bend out. So as you hang load on it, it's going to try to pull this corner in and sag. That's the concern I have. So I could add a flange to this piece, but then that would make it look worse. Because our inspiration does not have a flange there. It's beautiful. Maybe that's what I should do. I should add a flange to the... actually, what thickness was I using for that? Sheet metal. I might be able to tap it. 2 mil. 2 mil, 6061. Can I do tapping? Yes, I can do tapping. Tapping. Largest tap, M6 by 1. Ooh, this is cheaper than a PEM nut, I think. So what I'd basically do is make my beautiful cheese grater a bit smaller, and then I would flange that, make it a 50-52. So that's 2 mil. Yeah, I could do a flange to the top cover too. I was just thinking that this would be easier to nest together. So let's try that. So I have to take off, what's my bend radius? Well, what happens if I just add a flange? It is a sheet metal model after all. 2. You're going the wrong way. Okay, that way. And I want my dimensions to be flange alignment in. Okay, so I still have a material thickness. So I need to reduce the thickness of my part by 2 material thicknesses, which is 2 mil. Distance is going to be 20 mil. And these are going to be partial flanges. And how big were my flanges on this piece? Because they need to be that same size. How big are you? 27.5 mil. So they need to be 27.5 from the end. And a second bound, also 27.5. I'm not worried about the sidewalls themselves bending. I'm just worried about the connection. Yeah, so this is what I didn't want, was this ugliness here. So I need to clean that up somehow. So what do I want you to do is... partial flange. Do I have any more options? Automatic miter. So I need to lose like 4 mils here, back in my original sketch. So you're going to become... you need a full-length flange. I can't full-length flange because there's rack rails in the way. I can only mount to the front face of the rack rail, and I can't bend around the rack rail. I have to come in from there. You know what? I've decided I am going to revert to the last version. There we go. We're going to stick with the flat plate, no bending. And at the assembly level, we're going to stick with this. So the other thing I could do is I could add a stiffener to this corner, just to thicken it up a bit. That's what the case that I looked at did, but they're using a thinner steel than I am, I think. So this case that I've been looking at all day, what material thickness is that? You know, 48. Same as me. So they have a front piece, and then the motherboard tray comes in, and they have a stiffener that just goes about 3 inches down the corner. Let's see if I can show it on video. There's a stiffener piece that ends right here that just stiffens that corner. You know what I could do is make that part of the fan shroud. Let me make the fan shroud. Illustrate. Can I make a new part? Yeah, so the mounting gears are part of the sidewalls, and this piece, I just didn't cut the holes in them yet. So these are going to layer the front panel and the sidewalls. Okay, so now we're going to make the fan shroud, and I want to not... no. Just make a new sketch off this. Does it become a new part? No. I guess I'll just make a new part. Fan shroud. So how many fans do we need for a 2U system with power supply, RAM, 10 gig card, I don't know, 3 fans? They're going to come from Noctua because I want them to be quiet. Products, fans. Come on, load your fans. Size, 80 mil. Connector, 4-pin PWM. So these guys can do 55 cubic meters an hour, so that's like 25 CFM. I like very much. Noctua NFA8, how much does that cost? NFA8. 24 bucks. That's the whole cooler. That's the fan, 16 bucks. 3 of them? I'm spending more on fans than I am on like 10 gig cards. What if I just ask Amazon for a cheap 80 millimeter fan? 80 millimeter PC fan. King win. 4 bucks. In any case, it will use the same mounting dimensions. Hole spacing, 71.5 mil, okay. So back to you guys over here. So front, sketch. You're on the front plane, so I have my rectangle, it's my fan shroud. So my fan shroud is going to be 80 mil tall instead of 88 because it's going to hold the fans. And then I'm going to, so it's going to have the layer of steel on the bottom, probably like a 1 mil gap just for clearance, for bends and stuff, because I don't want to have it too big. Having a 1 mil gap would not be the worst for airflow, I don't think. So you're going to make this 80 mil tall, the exact height of the fan. 80, and width-wise, I need to fit inside this. And this is... How big did I make this? $430. Okay, 430 minus 2 material thicknesses takes me to 430 minus 1.25 minus 1.25. 427, so we're just going to say 427. Not 127, 427. 27. And then we're going to make it sit in the corner. And it is constrained. So many of my viewers are from Europe. Base of sketch, thickness. We are going to use, do we want to do this mid piece in aluminum or in steel? Steel is cheaper, I think. Okay, so then the fans. So let's sketch out where the fans are going to go, and I'm just going to pattern them. So I need a big ass circle for the airflow of the fan. Noctua. Do like a... So your 80 mil outer diameter, how big is the fan itself? So mounting holes are at 71.5. So I'm going to say 71.5. Hello, good afternoon. Okay, this is going to be halfway up, so it's going to be 40 mils up. Not 40 mils that way. No, 80 mils this way. 40 mils that way. So that's my hole for the fan. So let's make that a hole. And I'm taking a ton of material out of this piece, but I don't really care. It just holds the fans. So you're going to remove and you're going to go through all. Okay, so now we need some holes for the mounting. What size mounting holes does Noctua use? What size mounting holes would you use for a fan? It's like smaller than M4, isn't it? Like number 6? What diameter's as a number 6? 2.5. See, in the Imperial system, we can't even name holes based on what size they are. Number 6. Nominal drill size, number 18. Great. Hole diameter, 170. Okay, so what is 170 in metric? 6 mil. And number 6. $154 would be the close fit. 4. Okay, so it's probably about an M4. So I'm going to say we're going to make an M4 size hole. So it's going to be, nope. 4.25 mil, and it needs to be from the center of the hole. You guys need to be 71.5 apart. And then you, from this dimension, need to be 80 minus that. .25, 4.25, 4.25. Okay, new height. You should be 80, 40 minus. Should be there. Zero. There should be 0. There we go. Okay, so that is my hole pattern for the fan. We're going to go through all. Does that hole look big enough for the airflow of the fan? Maybe I should make it bigger. $2 mil gap. Let me think about 2 mil gap. How much do I like a 2 mil gap? Yeah, it's fine. So now I need to pattern these pieces for my giant fans. So we want to, where's the pattern button? There it is. We're going to do a feature pattern, and we're going to feature this extrude and that extrude. Direction is going to be this way. 80 mil enough? No, not even close. And 3 instances. 60, 120. How big is this part? This part is 430, I think. Measure and remember again. Yes, 430. Minus 427. And 33.5. Should be perfectly evenly spaced. Okay, there we go. 3 fans. They fit between the bottom plates. So this plate here is exactly 80 mils tall, which is the exact height of the fan. The chassis, so this plate here is 88 mils tall, which is the height of the 1U slot. So this is 86 mils. So I have material thickness on the top, which is 1.2 mils, material thickness on the bottom, which is 1.2 mils. I want to leave clearance for this radius in here. So basically there's going to be like a 2 mil. So 88 minus 1.22. Yes, it's going to be a 2.5 millimeter or 2.7 millimeter gap on the top and the bottom of this plate. All the way across. Because this plate is not going to touch the top and bottom perfectly. And I'm doing that because I'm sure the fit and finish is not going to be within a millimeter. So this will hold the fans, and then, yeah, so we are a sheet metal. So now I can do flanges, and these are going to come forward, and you will see the genius of this design soon. So these are going to come forward by, how thick should I have between the front face? I don't know, 30 mils? And you're going to be aligned outer. And then you're going to flange out like this. Not like that, like this. So this plate is going to sit between the aluminum front and the steel back. It's also going to get the rack screws bolted through it. And then I'm going to bolt on the side in here to stiffen up this corner. Isn't it beautiful? So if I use aluminum, I could tap it. Maybe I should use aluminum to tap it. Now I'll use steel with PEM nuts. I'm just going to put like 2 of them on each side or something. So this needs to be math. I know the answer, 27.5. There we go. How's that look? Oh, need some undercut there. Actually, no, you're wrapping around another flange, so you're fine. So now let's go to our assembly and add that part in. Not with hardware bolts and nuts, you need to tap the mounting holes. So my rack has the cage nuts, so I am going to mount it with, a lot of these are the rack screws going all the way through. Front panel. And shroud. And shroud part 1. Yeah, there we go. Okay. So now you need to get unmated. Oops. So you should be able to come out now. Planar mate top surface of this to the top surface of this. So this is going to kind of sit like, come on, stop being dumb. I'm going to make you grounded. MB tray. Has degrees of freedom. Please don't give it degrees of freedom. Fix. Oh no, node suppress. Fix. Okay, there we go. So you're fixed. You go there, and you go like that. So that's how it's going to look. At least that's my thought. So now we need to mate some stuff back together. So planar mate you, you. And I already did the top, so now I gotta do the ends. So this end is my reference. Planar mate you to you. Does the other side look like it's good? No, it looks a bit off. Oh, I know what I did wrong. I'm subtracting the material thickness. So you need to get 1.2 added. Actually, what number did I use for that material thickness? 427, so I used 1.5. So you need to get an extra 1.5 on each side. So you need to be 29. Okay. Version U. Mounting hardware. Oh yeah, bolts and nuts for the fan. So M4 bolts and nuts. You can get updated. There we go, that fits better. So now let's reconstrain this to this. There we go. Okay, so there we go. So now I want to put a bolt through this gap, and I can just use a regular hole in a bolt. I don't even have to use a PEM nut. But I could also use a PEM nut. So now we're going to go to U, change your hole pattern a bit. Just this one. So we need to move it 30 mils back. So you're going to be 60. This holds the top on. Actually, I'm going to delete one of these. I don't think I need... So you're going to be 300. You're going to be 80. Yeah, I forgot to dimension you top to bottom. No, I did dimension you. No, I didn't. There we go. So those are the screws that hold the top on. Come back up here. Yeah, we'll get to that eventually. So I need the screws that hold the side, or the stiffener end. So we're going to use M4s again, because we're using M4 for everything today. And this side is the one that does not get the PEM nut. So you're going to get an actual 4 mil. 4.25 mil. There you go. Yeah, I'm going 4.25. It'll be a tight fit. It's coming back from here in this dimension. I want to be 15 mils. So that face sticks out. I don't want that face to stick out. I should change that. And then U to U is going to be 0. And you guys vertically, you're going to be 60. And you from the bottom, you're going to be 20. No, you're going to be 10. No, the reason it's the shape that it is because it adds stiffness. So I bolt through from this piece to the fan mount, and it basically also adds a gusset in this corner to make this corner stronger. That's why the fan mount does what it does. Okay, so then I also want to change this. We'll extrude this first. Hello, I'm doing well. I'm gonna go through all. Why did I lose a hole? Supposed to be 2 holes. Supposed to be that one, you're supposed to be that one. Okay, that looks good. So then this flange here needs to be an outside flange, not an inside flange. Yes, I agree. Now let's version that, go back to the document, update your versions. Come on. Okay. Yeah, so this stacks up like here, so there's going to be a bolt that goes through here. Hold that together. So you are going to come down from the top. Should have mentioned you from the top. What is the dimension to the top? 14. Now I'm over constrained, but don't worry. Delete that one. Okay, so 15 from the top. So then you here are going to get a new sketch. And you're going to get some holes too. They're going to be PEM nut size. So PEM nuts, we're using M4 PEM nuts. They need a 212 hole. 538. $538. And apart, I think they were 60 apart. Looks about right. 15 from the top. And they're also 15 from this edge. That one's a 0 from the other one. Oops. Screws holding the fan mount to the sidewall need to be sunken. So they could either be countersunk, or I could rely on the fact that I actually have a bit of clearance because I made it a tiny bit smaller than the rack to begin with. So you two, come on, through all. That looks wrong. What's my dimension here? 60, yeah. 15, yeah, okay. Yeah, it does look a bit off. Let's fix that. Instead of 15, I'm going to go 12. Diversion U. All updates I've made. So here's what we have so far. So we have standoffs for motherboard, and we have motherboard tray. So let's make, I could either make the back panel, which is going to be complicated, or I could make the lid, which is not going to be complicated. So guess which one I'm going to make first? Hello, Alex from the UK. I should just make a folder for these. I can drop them all in the folder. Then I can stop naming them all to you home lab case. So you're going to be top. You're just called fan shroud. You're just called case. Case assy. You're called front. You're called MB tray. Let's try to remember our dimensions here. So we were going to be 430 by 420. So I'm on the front plane. So you are going to be 3D printing. I am going to make it at send, cut, send out of sheet metal. So 420 deep and 430 wide. Depth should, let's take a look at the assembly. So this piece is, so I need to cut a tiny bit off my depth due to this corner here. Actually, I just need to do an offset flange, which is fine. Probably offset all the way back past this so I don't get this screw. Or I could grab that screw. If I made that screw at 10 mil, then I could screw the case with that same screw. Can I recap the design goals? Yes. So at the very beginning, I opened up this slide. And this is, let me read it. So basically, I asked my people on Discord what they wanted to see in a ideal chassis. And here's what they voted on using emoji polls on Discord. They overwhelmingly said 2U. They were very split on what hard drives they wanted. They said no hot swap. They said internal PSU, and they said full-size ATX. So I thought about this, and I said, I would like to do 2U. That's reasonable. I would like to do 2.5-inch drives, and I would like about 4 of them or so. But if I can fit like 2 3.5-inch or 4 2.5 or something like that, that'd be great. No hot swap. I'm going to use an SFX power supply for airflow because ATX power supplies in a 2U case don't really have good airflow. And I decided on MATX as my form factor of choice because that's the board I already have. So also because I'm planning on buying used consumer hardware, there's a ton of MATX. So back over here. So why design versus buy? Because I've looked at like server cases online and I hated them all. So here is the case that I've currently been using for my server, and it fits 4 drives, and it like just replacing the fans in the front is such a pain in the ass because of how the fans are mounted. Like you have to take a whole case apart to get them out. This one has a 5 1/4 inch drive, which I definitely don't need. I want something like more modern. And I mean, it wasn't outrageously expensive. It would probably be like 60 or 70 bucks now. But I don't know, I figured this would be a fun project to build my own case. I also watched the horror of Linus Tech Devs building his own case and decided I could do better. Those his gaming PCs, though. So, yeah, so this is what we got so far. So we got a motherboard tray. These are all cutouts to use PEM standoffs. So those are standoffs, and they're going to be Imperial. Come on, Imperial. Do it. Reload. Yeah, so they're going to be these, nope, the thicker ones, these guys. So motherboard screws are, oh yeah, so standoffs, number 6. So these are going to be our standoffs. So number 632, we're going to hold the motherboard up. They're going to sit here. The motherboard's going to sit in that corner. So then we have space for power supply down here, and I can put some drives across the front sideways. So I think I could fit 3.5 inch drives here. I can definitely fit 2.5 inch drives here. So then I've got this beautiful front plate. Our inspiration for this is this beautiful Mac Pro. What about rails? Nope. Partly because of my own rack. So I have a 2-post network rack mounted at the ceiling with my patch panel and network switch and stuff, and I want to fit this in there. So this is basically as deep as I can go. It's about as deep as the one I already have, I guess I should say. So no rails, because this is going to be 2-post instead of 4-post, which will make it fit, and because it's so short, it should fit in a lot more racks. It's the hope. So it's 42 centimeters, so 420 millimeters deep. Okay, so I should yet again come and fix these holes here, and I want to put them 10 mil from the top. MB tray. So I want you to go 10 mil from the top. Oops. So that can hold the case, and then I can get rid of the other case bolt. 2-post custom slide rails. I am not going to make rails at all. Just to know. So you guys, this is going to be 10 mils from the top. And this is going to be how many mils from the back? Oops. Mention. Point 380. Like that. Okay, that has resolved. So we'll version it again, V6. Fan shroud, once again, editing these hole dimensions. So that's going to be 10 mil from the top, so it's going to take me to 9 on this hole. Okay, version U. How deep is the case? It is 420 millimeters deep, which in the imperial unit of measure is this many inches. That many, 16.5 inches. So it should fit where a lot of networking stuff fits, I hope. Now we're going to update you. Update you. Okay, so now time to build a lid. So it's going to be 420 by 430. So I got to remember, I got to keep track of which side. So this is the depth axis. Okay, and this is the front axis. So I'm going to have 2 flanges. Yeah, I know. I've looked at 2U cases, and none of them are that great. Okay, so you're going to come down. What's wrong with you? Oh, I need to make you sheet metal first. You're not even a sheet metal part. You're just a sketch. Picking. You're going to use steel. Yeah, the whole thing's going to be steel, except for the front panel, which is going to be brushed aluminum, which can optionally be anodized to look like a cheese grater Mac. So you, sheet metal model. Why did you not resolve properly? Oh, because I didn't pick a sketch. Okay. So then I need some flanges. Who's going to make your case? Send, cut, send. These are going to be 20 mils deep. Perfect. Actually, I need to make you a tad inboard. Partial flange on the front side and a distance of like 5 mils or something. That should be good. Okay, that's an odd looking corner, but we'll go with it. Actually, no, we're not going to go with it. Why not use front AO? Just for aesthetics. Front eye would make more sense. Really, it would. But I want it to look like cheese grater Mac. This is the picture we have open. I want to have a rack of them that look like this, except not super tall. That's why we have our best attempt at an off-brand cheese grater Mac case. Brushed aluminum. We're going to make you not a partial flange. So looking at how this fits together. So this is a inside corner. So this face is my 420. So I need to come back about 3 mils in the total length of the lid, not the so which one's my, you're the 420, so you need to become a 417. What are you going to make it out of? The front panel is going to be this 2 mil 6061 aluminum, which corresponds to 080 thickness. And the rest of the case is going to be 1008 mild steel 1.2 mil, which is 048 inches thick. The steel may be powder coated black, or it may be left as is. I don't know yet. And the front case could be anodized, beautiful, or it could be left as is and polished. Yeah, no, I'm not going to spend the money on... They do laser cutting and water jetting and sheet metal. They do sheet metal, basically. I guess they do sheet stuff. Okay, so then this needs... So this dimension here, what is the dimension of this hole? So I'm 15 from the front, but I'm cutting off 3 mils, so I'm 12 from the front on the top. Please tell me I got this dimension right. Yeah, I did. Okay, good. So here on this face, I need my mounting holes for the case, which are going to be M4 hardware. And so I need a front hole and a back hole. And you are going to be 4.25. No, stop it. 4.25. And oops. And you're also going to be... What the hell? I have no idea what I did with that. To you. 88 millimeters. Okay, so from the front, this one needs to be 15 minus the thickness I took off, which is 3 mils. That makes it 12. So you're 10 mils from the top here. A group buy. I don't know. Does anyone want cases? By the end of the live stream, I'm going to figure out how much it costs. So I've been on here for 2.5 hours, and I mean, I can just keep going until I'm done with this. So did I make you a... So you're thinking if I want this to nest. I want this to be a nice, good fit. The 20 mil flange. I'm going to put you 10 mils from the bottom, and that'll be tight. I think. One thing I can remember is that holes can always be made bigger. Never forget that. So this hole here, how far is it from the back? 380, okay. So you need to be 380 minus the 3, so 380 minus 377. So these are the holes in the lid. And we're going to cut them using the extrude tool. One. Got both of them through all. Okay, that's the lid. V1. I mean, you could paint graphics on it if you want. Let's add it to our assembly. It is top. Okay. What? Oh, I canceled before I hit accept. Materials should be cheap. Yeah, they should be cheap. Send Send has like a minimum price per operation type. So like if it's laser cut, there's like a price per square inch for laser cut forever material. And then that includes all the holes because they're laser cut. And then the bends, there's like a minimum price to do bending plus like 50 cents a bend or something like that. I don't know the exact prices. But that applies to the whole order, I think. I don't think I pay per part. Maybe it was just for duplicates. I only pay once for duplicates. I remember the exact. But it didn't seem that expensive to me for custom machining. Please. Why are you mad? What did I do wrong? Or whatever. We'll just do it again. Planar mate. So you need a surface. And you need a surface. There we go. So no two of these and no other obstacles in the rear. No, so SFX is thinner. So ATX is almost the exact height of a 2U chassis. And the case that I have now actually is designed to fit ATX. But if you use ATX, then you can't have a side mount fan on your power supply or you can't have clearance. But SFX is smaller. So with SFX, the power supply is in the volume of the case and air can come over the power supply and into the fan. So yeah, no, you can stack them. Okay, so I want to pick a surface here. Pick the damn surface. We're going to mate you with the back of the motherboard tray. There. Okay. That's a thing. So now I can move side to side. So now I got to stick this sheet to this sheet. Yes, please. Okay. Those holes don't quite line up. Where did a mistake get made? It's just these holes that don't quite line up. Okay, so you guys different. So you're 10 mil. Yeah, I actually have an ATX to SFX plate, but I'm just going to design it because I'm doing the CAD. I can just design it from the start to be SFX. You're also 10 mil, aren't you? What's wrong with me? Top. How is this hole wrong? How tall are you? 20 mil flange. Alignment inner. Oh, you should be alignment outer. No, you should be alignment inner. That was right. We'll move you down just a hair. Yeah, so that's basically how this is going. Almost 3 hours in, and seems to be working out pretty well. Now the back panel. I've been avoiding the back panel for a while now. So it has to nest into this. So it has to fold around on all four sides and fit in here. And yeah, so let's take a look at that. So let's open the MB tray for a sec. Where did I dimension the motherboard? This sketch. So I gave myself 10 mils. Not much. But you don't get space for wiring in a little tiny server case. So that's doing pretty good now. Somewhere here I had dimensions. Okay. Just one power supply. So board edge is at 0 mil. 1.1 mil is how much I gave myself for. There is no clearance here. Oops. Yeah, so these PCIe edge brackets like basically touch. So I'm not sure how I'm going to do this. So here's the cutout. So our case bottom is referenced to 0. Motherboard is at... Yes, that's the 532 post length. Okay. Yeah, I tried to find ATX with rear fan or front fan, and didn't seem great. I mean, we could look at power supplies now. Who makes good power supplies? I don't know. I'd hate to go Newegg and see what we find. Oh, 600 watt. Sound good? SFX. Dimensions. Maybe Corsair has nice drawings. Turn the light on here. Maybe this will help. There we go. Okay, so you are 60 SFX, SFXL. So 63.5 by 100 by 125. So 63. So we have 20 mils of clearance on the top. So from the top of this to the top of the case, which is at 88. So the whole case is 88 tall, and we're losing 1.2 on the bottom and 1.2 on the top. So then we have 63.5. We have 22 mils of clearance between the top of this power supply and the bottom surface of our case. So that's almost an inch. I think that airflow is going to be just fine. Either one of these. So SFXL is longer. That'll be fine. I don't think I need an SFXL for the power levels I'm looking for, but see if anyone has power supply mounting hole dimensions. This is efficiency curves. Power connectors. There we go. Okay. So we have a 40 mil fan. SFX 12V. 50 mil. It's a little bit different than what I was looking for. Yeah, 2 centimeter clearance, and this isn't going to be super high power, so this is going to be a Ryzen 3800 and a 10 gig card and a Tesla P4, which is bus powered. Maybe important existing backplate design. Yeah, maybe, or maybe not, I don't know. Just gonna... I'm just gonna make it myself. Okay, so my options are to reverse flare it or forward flare it. So this case is reverse bend. So the bend goes toward the back of the case, outside. So in that case, all the connections are recessed. And this causes the absolutely maddening problem where I can't get my, what is the thing called? My DAC, I have a direct attached copper cable that used to go in this slot here. And I couldn't get the retention clip out because of this stupid back panel design. So the advantage of doing it backwards like that is that I don't have the material thickness on the inside. Or I do it to give myself more space on the inside. Back. So let's do the back. So we need a sketch, front, maybe a rectangle. It's roughly like that. So let's measure. So how wide was this going to be? This was 430 minus the 2 material thicknesses. So I said 427. $427. And this is going to be something like 82 or something. So let's check. How tall did I make these flanges? How tall did I? So there's 84 plus my material thickness plus my case height. So I need to be, basically need to be 84. Okay, so then we're going to turn that into a sheet metal. Select the face. We're going to do steel again because we love steel. I have to bend it out, don't I? Actually, I have options. So here is my back plate. So now I need a set of flanges on some sides. I could just have flanges on the sides and not have them on the bottom. That might be easier. Then I wouldn't have clearance problems, but then I could separate. Maybe I should probably have flanges on all 4 sides. How big are you? You can do smaller flanges here because these are such a pain. 2, 3, 4. All of you are going to be aligned outer. You're going to be 16 mils. Yeah, like that. So the question is, should this side be the inside of the case, or should this side be the inside of the case? No, no motherboard plate. This is going straight to the case. Okay, so I'm going to drop this in. I'm going to give it a version and drop it in, just to see how it looks. I'm worried I'm going to hit these motherboard standoffs here, which might mean I have to do something different. Other documents. Yeah, so this is going to collide with some, I'm going to suppress visibility. If I refresh, is it going to figure out these names changed? No. Okay, so that's the top. So I'm going to suppress that. Yeah, so if this back piece sits, I think I need to face the back flanges out because I'm just not going to have enough space. Otherwise. Yeah, so I think what I'm going to do is I'm going to come to the MB tray here and I'm going to move the motherboard holes in by 16 mil. And that will get me space for the back flange to turn out. That is this one. So the MB tray clearance dimension is there, okay. So I need 1.14 mils to the plate. Okay, so we're going to move you back 16 mils. Update. And we will refresh. So that puts that back. So then I can face my flange outward. I also have the option of using pop rivets instead of PEM nuts. Or I could use threaded fasteners with bolts. Okay, get out of here. So let's mate you. Do you to you. Then we're going to do you to you. Yep, so this sits like this. Cut the edges of the black plate with small cuts to account for the bend radius of the top and bottom plates. They already are. So because I flanged all 4 corners, it automatically cut out the corner a little bit. Oh, I see what you mean. I should just make those slightly smaller flanges, I think. I should back the flange off by like a couple mils. Back. So you... Basically, I want to back the flange up so that it doesn't come into that area that it cut away automatically. I don't know, it's like 4 mils or something. Maybe 5 mils. How does that look? What the fuck happened to you? 4? 4? Happy? Not happy. Partial flange. How about 2 mils? Yeah, it doesn't like that. Why would we delete the flange and start over? So we're going to do bottom flange, top flange. You're a 16 mil flange, and you are going to be 4 mil from each end. I think the problem is when I flange this, now it's going to say there's some material that came out. I can't do it. If I take you like 5 mil in from each end, are you okay? Yeah, that's the problem. I'm going to just back you out just a tiny bit. What if we just do like 1 mil? So there's still a bit of that corner there. And we're still pissed. Automatic miter. The automatic miter might be causing a problem. Okay, I'm going to leave it. Actually, what if I turn off the automatic miter and I do it manually? Having a hard time computing this angle. I don't know why it's so hard for it. So what I want to do is cut it back to this point here. So it's 3 mils back. So if I partial flange it to 3 mils, there we go. Okay, that's much better. I like that. Okay. So I'm going to come back here. And I need to flush you up. Planar mate. You to you. You're building a case that looks like this out of sheet metal. Basically, that's it. How thick is this total piece on the back? So from you, nope. I need to subtract material thickness, I think. From you to you. Stop it. Stop clicking things. Okay. So I want to measure from you to you, 16.15 mil. It is 16 mil from the bottom, okay. 30 is going to be from the top. Okay. So let's version this because we made changes. Where else do we make changes to? You've been updated. Yeah, so we're working on the motherboard flange now. So motherboard mount is going to mount with standoffs off the bottom that are pressed in. Got the holes for them here. That's a micro ATX or MATX form factor. We're going to put an SFX power supply here. We can put drives here. Not a lot of drives, but just a couple drives, which should be enough for most people that do home lab stuff, because we don't need a ton of drives. We just need, like, enough drives. At least that's my opinion. I would be perfectly happy with 2 hard drives and a mirror, or like 4 to 6 SSDs. Okay, so now I need to make the motherboard cutout in the back. So you are going to get a motherboard cutout. I just want like the exact features that I want, and that's basically it. So you cutout needs to be 44.7 tall. I'm going to drag this tab over here. 44.7 tall. 44.7 tall, and you are 159 width. Actually, there's a constraint somewhere that's not right. You are locked. Oops. Let me sketch on here. Need a rectangle. Phone is ringing. Shut up. Yeah, so my thought for the hard drives was to put some PEM nuts on the bottom and then design 2 separate sets of brackets. One that can hold hard drives, one that can hold SSDs. And then I can use one of those 2 brackets, basically. 159. And height is 44.7. So you need to be, go back. Stop it. Open image in new tab. There we go. Okay. So post. So I'm using the 375 inch threaded post length, 0.375 inch. So that's off the bottom surface. Takes me up to the motherboard. So the cutout needs to start at 7.30 millimeters from the bottom. So you need to be here, 7.30. And then in the other dimension, I have to figure out what the dimension is. It's 10. It's 10 mils. That's what I gave myself. No, but it's minus the material thickness. Oh my god, material thickness. So you're 10 mils from... there. Okay. Does that seem right? I open my sketch for the motherboard tray. How much space did I give myself? I gave myself 10 mils from the outside. Okay, that's right. So that is the cutout for the motherboard. For the, not the motherboard, the I/O. Motherboard I/O. Okay. So now I version this so I can import it in the other one. Get it all, and it's probably going to be in the wrong place. Oh, it's right. Perfect. Okay. There's like always a chance that you had like constrained it, flipped over or something. Okay. So motherboard shroud goes there. So now I need 4 PCIe slots because that's how many you get with How much memory do all these Onshape tabs use? Let's see. Firefox is currently using 5 gigabytes of RAM. Actually, what's using all my RAM is DaVinci Resolve. We're going to yeet that one out of here for now. Fuck off, DaVinci Resolve. Okay, that's much better. Onshape is not outrageous. It's surprisingly efficient. Okay, so then we have to start these cutouts here. Ooh, so these tabs actually stick below the... How much do they stick below? Oops, go back. This one I already have open, isn't it? Okay, so that's the cutout. Do these actually stick below? Or not? Because I don't have space for them to stick below. They gotta sit in the case there. We'll figure this out. I'll sand them if I have to. Okay, so now let's measure these I/O cutouts on our backplane. And these are full height. I need half height. You guys have half height? Mini ITX. Ugh. Just measure it myself. Low profile cards, height. That is the PCB. Thankfully, I have a low profile card right here I can measure. It's MikroTik. I haven't used it yet, but I took videos of it. So this is the CRS 2004, 25 gig. And it is going in this exact server I'm building, so it better fit. Let's see, so from the top down, it's telling me, yes, it's a router on a PCIe card. So this is two 25 gig and one 1 gig, and then it shows up to the PCIe host as 4 Ethernet cards. And in RouterOS, you can bridge them or VLAN tag them or whatever you want. So this is actually, it runs RouterOS, MikroTik RouterOS, which is Linux-based. And the what's it called? The chip it uses is made by Annapurna Labs, which is the same company that Amazon bought to make their AWS Nitro cards, which are the hypervisor offload cards. So this could be used in a data center to do like VXLAN tagging and untagging. So if you sell like a bare metal server to a client or something, you could have this do VXLAN for you for your virtual networking. Or if you're like coloing, you could use this as your router so you don't have to have another router if you don't want to do a software router. I don't exactly know what they were thinking, but I bought it and I'm going to use it. You can also use it as a 25 gig card too. So the motherboard I have that open too, is this guy. So we have a blank space, 2, 3, blank space. Yeah, so I could put a dual slot card in the bottom. Let's put 5 slots. So I need to figure out how this dimension. So that current dimension, that's 93. I have a feeling it's going to be closer to like 60, 70. Yeah, so to where it starts to neck, I'm measuring 68 mils from the bottom of this to where it starts to neck on my real card here. So that's what I'm going to use as my dimension. That is this piece. So we're going to sketch again on this face, and we're going to make a rectangular hole. So where do we, so we're going to be 68 mils tall. 68, that's got some clearance. What's our width? relief cutout there, 15.88. Okay, so that's our PCIe clearance. That is quite big. That includes what they call the relief cutout here, though. Yeah, so we can do routing. Seems wide. One of the problems is I don't have a ton of hardware that can do 25 gig to test it. So at best, I can take a 25 gig like Mellanox card and compare that and just use it as the other side of the link. Microtik has some performance data though on their end. Okay, so we measure that at 68. So we're sticking with 68 instead of this. How high does this go off? This doesn't tell me. So measuring up from the bottom. So the I/O cutout ends here. So here to there, the center line of that card, 75. So from my I/O cutout, how far do I need to go? From here to here, I need to go 87.4 minus 75.13. Fuck. Calculator. So we got to do 87.4 minus 75.13 plus half the width, which is 15. So 12 is the distance to the center line minus 15.88 over 2. 4.33. Okay, that's not much. So then what about my bottom clearance? Where is that in the picture? From this cutout up to there, that must be another figure. That lines up with the motherboard, doesn't it? No, that cutout doesn't. The card does. The clearance cutout does not. What is this dimension here? 8 mil. Okay, 8 mil off the surface of the board, which 8.06 mil off the board. So this to this, 8.06 plus, actually this goes in the wrong direction. This needs to be up here. So here to here, I have 8.06 off the surface of the board, plus the difference between the board and the I/O cutout, which is 9.53 minus 7.3. And that seems off to me. That takes me out of the top of the case. That does not seem right. $8 mil. Is it that high up? Oh no, that's the clearance. Okay, so no, I'm going down to 0. Okay. I'm giving myself more clearance here. Look at the real one. It is a bit up. It's quite high up. Okay. So I might have to change this design a bit. It does not go past the bottom of the case. It touches the bottom of the case. So this needs to be that dimension. There, because I was making my cutout go all the way down to the bottom. Because I measured my cutout differently. Okay, so this is my cutout. So I'm going to cut it out. I'm going to round the corners a little bit. Yeah. I'm going to do you. That's a lot. How about 3 mils? 2 mils? Yeah, let's do that. Okay. So that is my cutout. Now what is the spacing of the cutouts? This extrude and that fillet need to get linear patterned. We're going to feature pattern, and we're going to feature this and this in this direction. What is your spacing? You are math. So you are 136. 09 minus 155, 115.77. 20.32 is the pitch. And we're going to have 5 of them. There we go. Cutouts for the brackets. Next up is the screw mounting for the brackets. So this one is going to be tricky. I'm not sure what I want to do with this. Does the card bracket go past? No, it doesn't. I already answered that. I'm going to break everything. Actually, I'm going to do a... thinking of how I want to do this. I think I want to carry that hole through the cut, fold it over, and have room to screw the cards in. I don't think I can tap this material thickness. Let's ask. So 1.22 mil, you cannot get tapped. What if I go up to 1.5 mil? Okay. Maybe I should make this part of 1.5 mil then. What is that? 0.49, okay. Just so I can tap it. Sheet metal model. What, copper, 1.5 mil. And what's your bend radius? 2.84. Okay, did the model figure itself? Yes, it did. Okay. So now I have a material that I can tap. So now what I want to do is I want to bring this top flange down until it cuts through this. So I have a flange that is being cut. And then I'm just going to screw the screws directly in. I know this probably sounds weird. I get a slot and screw it from the bottom. Yeah, so I don't know how wide the flanges have a bit of an odd geometry to them. Like if I look at a PCI bracket, it's not straight head on. It has a little side jig to it. I don't know if you can see in camera. So instead of keystone, I could just get some PCI brackets and put them in the PCI slot. Oh no. You need to come from this side. Okay, so next up, I'm going to cut down out of this. Oh, fuck. Let's see what the bend tool likes. Because I kind of want to bend it, like I want to do a cut here and a cut here and then bend that whole top over. And carry this cut with me. Bend relief. So what I really need to do is do this cut after I do the flange, I think. So what is the thickness here? So like from you to you, I got 6.7 mil. So I need to bring the top down 6.7 mil and then bend it. That'll give me a space for this bracket. Oops. You're not a part sketch. Okay. Yeah, like that. And then I want this to be from here to here. Needs some material space. 14 mil. I'll do the same on this side. 14 mil. I move you up before these guys. And we're going to do a cut. I need to generate properly. Oh yeah, you're right. Math. I gotta do math. Fuck. Okay, now you regenerate properly. Oh, depth. There we go. Oop, I want to do that extrude. Nope, I want to move you up here. You down there. Okay, so now I can put a flange here. First I can put 2 flanges on the side. You and you. You're going to be a 16 mil flange. Your bend is an outer. And you are partial by 3 mils. Okay, so that kind of fucked up in the inner, but that's whatever. Okay, so now I can flange this. Oh, no, you don't need a partial on the other side. Hold on. Ah. 1 flange at a time. You flange. 16. Outer. Partial. Oops. 0. Second bound. 3. You flange. Flange. Outer. 16 mil. Partial flange. 3. There we go. You flange. Again. Outer. 16 mil. Partial flange. 5 mil and 5 mil. That's a really bizarre looking cut, but I think the machine can do it. So what happens if we do this? Oh, that's beautiful. I like that very much. I don't know if the machine will like that, but I like it. Fillet. Yeah, fuck the fillet. Whatever. And we're going to get rid of that feature. Why is it pissed? 20.32, okay. Pattern. Where's my pattern button? There it is. Run a pattern. Feature pattern. Pattern the extrude, or a direction is going to be that way. Maybe 5 of them. Are you like not patternable or something? Hmm. So to use the PCI card, sit on this and then screw down. I'm curious what my total cost is so far. So I'm going to save a revision of this. Oop, I guess not. It's broken. How much is the motherboard tray? Can I export you? What I really want is to export the sheet metal. How do I get the flat pattern? There's a view for this. I'm not an on-shape expert. Oh, this. There we go. Export DXF. Okay. DXF. How much would this one piece cost at 10 cut sand? Do I not have an account? Let's see. Okay. So this needs... Okay, so this piece is going to be mild steel. And it's going to be 1.2 mil. It's like half the price if I get 2 of them. Okay. Bending. 90. 90. 90, 90. There. That is not right. That's better. Okay. No finish. Nope. Hardware. So these guys get... There's 2 different pieces of hardware. These guys get the PEM nuts. M4. And these guys get the standoffs. The number 6 by 375. How many of you guys are there? Supposed to be 8 of you and 2 of you. Yeah, that's right. Okay, these guys are the standoffs. $100 for the motherboard tray, which is the most complicated part. If I buy 2 of them, it is very significantly cheaper. Okay. I'll add that to cart. Next up, the front. Oh, I timed out. This one, we are going to flat view. I'm going to export you as well. So we can come back here. Front panel, this one's going to be aluminum. You're doing 6061 2 mil. Okay. Metals, aluminum. Is it cheaper? $50. $74 for 6061 or same price. No hardware, no bending, just cutting. Ooh, what if we anodize it gold? How much does that cost? It costs more. But it looks cool. I'm going to clear and start with just deburring. Okay. Did I accidentally add 2 things to my cart? Yeah, we added that twice. Okay, so we're looking at a few $100 in metal here. Next, I need the fan bracket. Okay, fan bracket. Add more drawings. Didn't offer deburring. Might be too big. Don't know. Downloads, fan shroud. Okay, fan shroud. You are millimeters. You are metal. Steel. Mild steel. 048. That's a very cheap piece. Okay, nice. Bending. All of you are 90. Yeah, like that. You have fasteners. No finish. Services. Hardware. You need a nut. M6. M4. PEM nut. Okay. Okay, so my cart total so far would be 200 bucks. And if I want 2 of them, it would be 291. So I really don't want to buy 2 of them until I'm sure that it works, but also good enough with metalworking that I could probably make it work even if it didn't quite fit. The back panel, though, is what I'm going to struggle with. And the top. It's probably going to be kind of costly because of how big it is. So we got a DXF, more drawings. Top. Yes, metric. Steel. 48. Bending. No hardware. Finishings. They do allow powder coating, so gloss black. How much is that? So I go from 59 bucks to 185. Fucking hell. Okay. Maybe I should powder coat it myself. Add powder coating to you and see how much that is in my total cart. Yeah, so it's too big to powder coat. That's the problem. They have a limit on size for powder coating. I'm going to get rid of powder coating on you too. I'm just going to bare steel. I guess I'll paint it myself. So again, I get 3 of them. It's way cheaper to get 2 cases instead of 1. So I still need the back plate, and the back plate is complicated. So what if I try to unfold the back plate right now? It's going to be like, what do you want to do? Yeah, I got to finish the back plate. But basically, I'm going to finish the back plate. I've been streaming for 3 hours. 4 hours, almost 4 hours. Wow. So I need a bit of a break. But yeah, so I'm going to finish the back plate, figure out how I can get this to be happy. And once I do that, I'm going to put together a shopping cart on Send Cut Send. And yeah, I was hoping to build a prototype before I offered it to any of you guys, but I'm still going to do that, I think. I'm going to make a video about it, and then I'm going to offer it to you guys. If you would like it. Some sort of group buy or something. Yeah, I am. I'm trying to get the functional cutouts done first before I do the non-functional cutouts. So I'm trying to get the motherboard mount and the power supply mount finished before I start adding ventilation. But I could do like a microtick style. I really like this look for ventilation holes. So they do this like pattern that's kind of like a bunch of nested V's across, and they're easy to make, so I could make a bunch of V-shaped slots like nested into each other all the way down. Probably across here, and then this will have the PCIe bracket, so probably no ventilation there. Then probably a bit of ventilation here, and then the power supply. So that's how it's going to look when it's done.
So where were we at? Yeah, so this is the whole case. By turning this back on, this is what it looks like. So this is going to be aluminum. Can I set material for you? Like a render material? I don't know. But anyway, this is what it's going to look like. So it's going to have this beautiful brushed aluminum front. It's brushed. And then behind the brushed aluminum front is the fan shroud that is structural but also holds three 80mm fans. And I was thinking about just putting a fan grill on each of them, that I buy a fan grill. So then the dust is around the fans here, and I can take the lid off and vacuum it to clean it. That way I don't have dust accumulating on my beautiful aluminum holes here. Then on the inside, I obviously have the motherboard and stuff. On the back plate, I have the outgoing air. Yeah, so that's basically the plan. Thanks for coming along, guys. I know I've had just 659 viewers today. That's really cool. So I'm going to take a break and have dinner, and then I'm going to try to finish up this back plate offline and see if I can find a way to make it work in the way that I like. And then once I do that, I'll probably send it out to get made. And don't expect a video on like finishing this for a while, because even if I order it today, Senkatsen would take it like a week to make it. But and then I would have to buy the rest of the parts, and I'd have to buy, I have a power supply, but I have to buy the rest of the parts. And some of them are already coming in the mail, and some of them aren't, so it'll be at least a month before this goes together, for sure. Probably more. So, yeah, thanks for coming, guys. I'm gonna head out now. It's a holiday weekend for me, so no video on Monday, but I should be video out on Tuesday. So, yep, thanks for coming. Bye.